Hello, screen is visible.
Sir, visible, sir.
Okay. So single phase semi converter I have taken. So if source inductance will be there, what will be the waveform of the current across the switches or diode? Okay. So this is the basic configuration, like with freewheeling diode. One by one, I will take all the three configurations which I have discussed earlier. So this is with freewheeling diodes. All four thyristors are there: T1, T2, T3, T4, and one freewheeling diode is there, and this source inductance is L. Okay. So first I will draw the waveform without the effect of the source inductance. So let's say this is source voltage. Okay. So what will be the output voltage? The output voltage will be, let's say here it is alpha. So I'm drawing output voltage here, and here it is pi plus alpha. So this is the output voltage here to here and here to here. So alpha to pi and pi plus alpha to 2 pi, and current will be here alpha to pi T1 will conduct, and T1 T2 here T3 T4, and in between diode will conduct, freewheeling diode here also and here also. Okay. So what will be the current of the across the source? So source current will be T1 minus T2. This is IT1, and here it is T4. So IT1 minus IT4 is the source current. Okay. So here to here T1 is conducting, again freewheeling diode. Okay. Here it is large, but it should be considered a small one. 0 to alpha. It is alpha. It is pi, pi plus alpha, and here it is 2 pi. Okay. But this current will not suddenly go from 0 to 1. What will happen? I'm going to draw all the waveform. So let's say before alpha, what is conducting, or freewheeling diode is conducting. Okay. So here at alpha, what will happen? Diode will become 0. Okay. And this T1, T2 will start conducting. So this green, this black color waveform is T1, T2. So it will be like this. Okay. This red color is freewheeling diode. Again, this black will go up to here. T1, T2 this is T1, T2. Again here what will happen? This freewheeling diode 0, here it will, again what will happen? It will start conducting. So it will be like this. Okay. And this one will be here. Again here it will go up to here. And next time what will happen? Next time here this red color is the freewheeling diode. So again what will happen here? Here this uh, black color was the T1, T2. Again here what will happen? This freewheeling diode will become 0, and from here the current will be picked up by T3, T4. So this will be like this, and here T3, T4 will pick up that current. Okay. Again T3, T4 will become 0 like this one. Here I am drawing, and that same current will be taken care by the freewheeling diode. Is this waveform is clear? Otherwise I will explain again. So this is mu here. This is also mu. This is also same. I am drawing different length, but length will be same. All will be mu. Okay, so when freewheeling diode will either transfer to T1, T2 or T3, T4, that time it will be mu. Is it clear? Hello. You
Yes,
can.
sir. Yes, sir.
Yes, sir.
Okay. So see what is happening here. for the freewheeling time, what will happen? T1, T2 and freewheeling diode. So if T1, T2 and freewheeling diode all will conduct, what will happen? Across output, that for that duration, the voltage will be 0. Okay. So if we come to this waveform output voltage will be 0. And here also, because of this one here, this second mu, this will be 0. Okay. So see here, if we are seeing one extra mu, so one extra mu is there, but in that place already in normal case also output voltage is 0 only. Okay. This second mu for here and second mu for here is causing the reduction in the output voltage. Okay. And if we'll see the current, this current here, is, so is will become 0 to I naught. Like if we will see in the full bridge converter, there it was going from minus I naught to I naught, but here if we'll see, this is the source current. Okay, so it will go 0 to I naught. Okay, so this is alpha, this point is alpha plus mu. So we can integrate for this duration what is the drop in the voltage, delta V. Okay, so delta V we can calculate VL is equal to L into di by dt. Okay, same I am going to calculate. So delta V, how we can calculate? V dt. Okay, so Vm sine of omega t alpha to alpha plus mu. This should be equal to into d omega t. This no, here it will be dt, because L di by dt we are applying, so it will not be omega t, it will be dt here. Sin omega t dt, this should be equal to L into integral of di. I will be 0 to I naught. Okay. So it will be Vm upon omega into minus cos omega t alpha to alpha plus mu. Okay. And here it will be L into I naught. Okay. So further we can simplify this. So it will be Vm. It will be here, it will be cos alpha minus cos alpha plus mu. So cos alpha minus cos alpha plus mu, this should be equal to, here it is omega into Li0, omega into L into I naught. Okay, is it clear up to now? Hello.
Sir, yes, sir.
Okay, so omega will be 2 pi. Okay, so Vm upon 2 pi cos alpha minus cos alpha plus mu, this should be equal to, no, here I am taking pi only. Okay, so it will be 2f Li naught. And if you'll see the output voltage of the normal this semi converter, so it will be Vm upon pi 1 plus cos alpha. So what will be the Vd0 for this? Vd0 will be 2 Vm upon pi, and Vd0 by 2 will be Vm upon pi. Okay, so we can write as like delta Vd0. Same I am converting into the previous form so that it will be easy to remember. So delta Vd0 will be Vd0 upon 2 cos of alpha minus cos alpha plus mu. Okay, so this is same, but here that another formula is delta Vd0 in terms of frequency is 2f Ls I naught. Okay, so this only we have to remember for this one. Okay, all the converters, what formula I have summarized there, delta Vd0 is same. This pattern only we are following. Okay, so this should be same only here also, but delta Vd0 is 2 FLS I naught. For normal full bridge converter it was 4 FLS I naught. Okay, 4 FLS I naught. So like this we can remember, for normal it was 4 FLS I naught. So for the semi it is 2 FLS
Yes,
I naught. Okay, just to remember it, like we can remember like that. Is it okay? Hello, am I audible?
Audible, sir. You are audible, sir.
Is it clear? So this you have to remember this formula. Okay, because this we have framed in same way as earlier. A standard formula delta VD0 should be equal to VD0 by 2 cos alpha minus cos alpha plus mu. So this only we have to remember. Okay. And what will be the output voltage? So output voltage is also not generalized. Like this we have generalized, but output voltage if we'll calculate here, so VO will be normal V naught minus delta VD0. Okay, so normal V naught is Vm upon pi, okay, to 1 plus cos alpha minus of this one. So minus Vm upon pi cos alpha minus cos alpha plus mu. Okay. So that will be Vm upon pi, okay, 1 plus cos alpha plus mu. So this will be the output voltage. Okay. This will be the output voltage. So to avoid the confusion, how we can memorize? We can memorize this formula only. This formula you should memorize. Okay. And for where is the exception are, like for output voltage, one formula I wrote, VO is equal to VD0 upon 2 into cos alpha plus mu. This is valid only for single phase half bridge, half wave rectifier. Okay, no, this will not be valid for single phase half wave and single phase semi converter. For this only, this will not be valid. Okay, so how we can calculate the output voltage in this case? Every case we can calculate the output voltage means normal output minus delta VD0. Okay, so like this you can remember. Is it clear? Hello. So see, we can calculate. Can anyone tell what will be the duration of conduction of the thyristor T1 from this waveform? How much angle thyristor T1 will conduct? T1 will conduct for how much duration? From this waveform, can anyone reply? What will be the conduction angle of thyristor T1? Normally, what will be the conduction angle without freewheeling?
Pi plus mu, sir.
No. You carefully observe the waveform. Like without inductance effect, what will be the let's say inductance effect is not there, then what will be the conduction angle?
Pi
Already,
minus alpha.
yes, pi minus alpha. Now you see the waveform again. I have drawn the current T1 T2 current, okay, with black color. So what will be the angle? It is starting from here. It is starting from alpha. Okay, it is going here T1 T2 current. Okay, it is going up to here. Again after pi, it will go up to here. If you'll see here, again pi plus alpha, this is flowing pi plus alpha to 2 pi. Okay, after 2 pi also, it is going here up to mu. So T1 T2 will conduct for how much degree? Can anyone reply now? It's visible na? Here to here. How much will be the angle? Can anyone reply? See, here to here how much? Already we have calculated. Here to here how much? Pi minus alpha. And this extra mu?
Sir, pi plus mu minus alpha.
Oh, okay. Pi minus alpha. Already we have plus mu. Okay. So already we have observed this sequence, like whatever will be the conduction angle without overlapping, same value is adding. Like I have discussed the formula for three phase rectifier also. Okay, there also we got the same thing, like pi minus alpha plus mu. So T2 also if you'll see T2 T3, T2 and T3. Okay, this is green color is T2 T3. So it is starting from pi plus alpha up to 2 pi. Okay, again here 2 pi it will start decreasing. So that waveform I have drawn here. So 2 pi minus alpha, that will be pi minus alpha. So here to here how much? Pi minus alpha plus this mu. So T3 T4 also will be pi minus alpha plus mu. Is it clear? Is it clear? Can anyone reply?
Yes, sir. Clear, sir.
Okay. So what will be the conduction angle of diode? Can anyone tell from this waveform? What will be the conduction angle of the diode? Before what is
Sir,
the
pi plus alpha plus mu.
no no you see the carefully the waveform where the diode is conducting. Okay. See before what is the before diode is conducting in this duration and this duration freewheeling diode. Okay. Here also alpha is there. Here also alpha is there. So before if we'll see the already I have derived that formula. So diode will conduct for 2 alpha in 360 degree. Okay. So what will the RMS value? I naught into 2 alpha divided by 2 pi I naught into alpha by pi. That formula we already know. It means that it is conducting for 2 alpha in 1 2 pi. Okay. So what is happening if freewheeling is happening? So if you see here, diode is start conducting from here. They start conduct up to alpha, okay, and here mu. So here if you see here to here alpha plus mu, again if you see here to here alpha and alpha plus mu. So in 360 degree, how much diode is conducting? 2 into alpha plus mu. Is it clear? Clear to all?
Yes, sir.
Okay, okay. So if numerical will be asked like thyristor conduction angle pi minus alpha plus mu, okay, and freewheeling diode conduction angle how much? Alpha plus mu into 2 for 360 degree. Okay, in one cycle this is the conduction angle, and formula will be used. Which formula will be used? So this one here 2 FLS I naught it will be. Okay, so I'm moving to the next configuration of this one only. So this is one of the configuration of the semi converter. Okay, so here I what that average and output voltage will be the same. Okay, only the difference will be the conduction angle of thyristor and diode. So I'm going to draw the waveform first. Okay, so this is source voltage. Okay, and here 1 second. So output voltage. So this is alpha. This is alpha, and here it will come. So this is output voltage normally without freewheeling and without this inductor effect. Okay, so first time I'm going to draw the waveform without inductor effect. So it will be here to here. Let's say initially which one will conduct? T1 D2 will start conducting from here. Okay, T1 D2. So alpha T1 D2 start conducting, and what will happen here? Just it will be become negative. So at that time, that T1 and D4 will start freewheeling. Okay, so T1 D4 will conduct from up to here. So this is IT1 waveform. Okay, here to here T1 and D2 is conducting. Here to here T1 D4 is conducting. Similarly, I'm going to draw the ID4 waveform. Okay, so D4 waveform will be, it will start from here. Okay, T1 D4 is conducting, and here what will happen? If we'll turn on the T3, then T3 and D4 will conduct. Okay, and if we'll subtract this waveform, then we'll get IT1 minus ID4. So that will be the source current. A source current will be same here to here alpha to pi, and again it will be 0 from for here. So this will be like this. This is the source current. This is without inductor effect. Is it clear? This waveform is without inductor effect. Can you reply? Hello.
Yes, sir.
Okay. So if you'll see, I'm going to draw IT3 and IT1 on the same waveform. Okay. So first I will draw the source current waveform. This is source current. Then I will draw IT3 and IT1. So alpha 2 pi and again pi plus alpha 2 2 pi, pi plus alpha 2 2 pi. So let's say here IT1 will start conducting here at alpha. Okay. So before alpha IT1 will be 0, IT1 will start conducting and it will become I0, and before IT3 will conduct. Okay. So IT3 will conduct before and this will become 0 here. It will become 0. Okay. And T1 will conduct up to how much? It will conduct up to pi plus alpha. 1 second. It will conduct up to pi plus alpha here. And this T3 will start here. It will go at top and again this will go at bottom. So this black color waveform is IT1. No, 1 second. This is IT3 and this red color is IT1. Is it clear? This waveform. This will be mu and this will be mu. This waveform is clear to all? Hello. See, already we have derived this formula. What will be the formula in normal case? How much time T1 will conduct? So T1 will conduct for how much duration? Pi plus pi minus alpha or pi plus alpha? Hmm?
Minus alpha.
Hmm? No, for this case. How much it will conduct? Pi plus alpha or pi minus alpha? T1 will conduct for pi minus alpha.
Sir, I think only pi duration will conduct.
Mm-hmm. It will not conduct for pi minus alpha or pi plus alpha. It will conduct for pi because this is a symmetrical configuration. Okay.
Yes, sir.
In next configuration, it will conduct for pi minus. So since this is here alpha and this value is pi plus alpha, so normally it is conducting for 180 degree, and this is also conducting for 180 degree. So normal case we have derived the formula IT RMS is equal to 180 divided by 360 into I naught. That is I naught by root 2. Okay. So in this case, diode also will conduct for 180 degree and diode current will be I naught by root 2 without source inductance. Okay. But here what is happening? If you'll see here, this is starting from here. So here to here, 180 and this mu. Okay. So we can say that the thyristor, okay, T1 and T3 will conduct for 180 plus mu. Is it clear? Hello.
Yes, sir.
So similarly, if you'll observe, diode also will conduct for same degree. Diode, should we draw that waveform also for diode? So where it will be? 1 second. I mean this one, and top I will draw the diode waveform. Okay. So, D2 will conduct from where? D2 will start, no, D4 will start conducting after this one. 1 second. D4 is start conducting after this point. Okay, so this point D4 will start conducting. So here let's say this D4 and it is going. Before this, which will be conducting, D3 will be conducting. Okay. So this is no D2 D4 no D2 and D4. This is D2 and this is D4. Okay. Again, it will go back. If you trace it back, it will come up to here. Okay. And it will, here it will be 0, and it will be like this. So after 2 pi again, this D2 will be 0, and D1, no, this is D2, and this green, no, no, I'm doing some mistake. So this red color is D4, okay, and this green color is D2. Is it clear? We'll see this waveform here, this waveform. So if you'll see here, till here D2 was conducting. After this pi, T1, D4 was starting the freewheeling. Okay. So D2 will become 0 here at this instant, at pi instant, and D4 will become I naught again up to here. Here also what will happen after 2 pi? After 2 pi again, D1, D2 will start conducting. So D2 will from 0 to I naught, and D4 will become 0. Is it clear? This waveforms are clear? Hello? Normally the waveforms will be like normal condition waveforms will be for D2, it will be 0 to pi, and no, here, 1 second. So D2 is conducting here also, and 1 second. T1, D4, we are here, which will conduct? This side. T1, D4, T1, D2, T1, D4, and
T3 D4.
T3, D4. Okay. So if you'll see here, it is conduct D4 is conducting here to here, and D2 is conducting here to here. D2 here also D2 will conduct. So D2 is conducting for 180 degree, and D4 is also conducting for 180 degree. But if you'll see here, this is D2. If you'll see 180 plus mu. Okay. So you can say D2 and D4, 180 plus mu, and T1, T3, 180 plus mu. Is it clear? So our observation is correct here also. Like already we have observed in all the previous cases, everywhere we are getting whatever will be the actual angle plus the overlap angle. Okay, is it clear?
Yes, sir.
Okay. So next case is this one. This is a symmetrical configuration. So here I am just going to draw the normal case. What will be the in the normal case? Same thing will be there. Plus mu we can add. Okay. So this is source voltage, and we can, so this, let's say alpha, so this will be the output voltage here to here and here to here, alpha pi plus alpha 2 pi. Okay. So alpha to pi, which switches will conduct? Alpha to pi, T1, D2. Here T1, D2. Here again what will happen? T2, D3. Okay. And here D2, D3 will be freewheeling. Again here D3, T4. T4, D3, and here D2, D3. Is it clear? So what will be the conduction angle of diode? Can anyone tell? Thyristor it will be pi minus alpha normally, and diode it will be pi plus alpha. Is it clear? Without overlapping. Is it clear?
Yes, sir.
So with overlapping, just we have to add the mu. If overlapping effect will be there, so T will be pi minus alpha plus mu, and D will be pi plus alpha plus mu. Okay. This you can visualize the waveform by drawing. Okay, and like let's say D3, D2 and D3. Okay, so D2 is conducting here. D2 is there. D2 is there. So what will happen? D2 will D2 is conducting here also, here also, here also, here also. But here D2 will become 0. Okay. If we'll go from here to here, D2. So D2 will not suddenly become 0. It will make a slope. Okay. So that, and here some like which one? T4 is there. So T4 is previously 0. 0, 0. Again it will make mu. Okay. So we'll see here pi plus alpha plus mu. Okay. Is it clear? Similarly, for thyristor, if we'll see what will happen, thyristor is conducting from alpha. Alpha it will start, okay, up to pi, and pi again it will start decreasing. So if we'll see here to here, it is pi minus alpha, and it will be pi minus alpha plus mu. Is it clear? Hello? Can anyone reply? So
Yes, sir.
one thing we should remember, it will work in every case. Whatever will be the actual angle without the overlapping, that should mu should be added. Okay. So whatever will without source inductance will get the angle, in that angle plus mu, that will be the conduction angle of that particular switch or diode with the source inductance effect. Okay. So I think now rectifier portion is completed. Most of the things I have covered, and only one thing is remaining. I think three phase. That much tough question they will not ask in GATE, like three phase semi converter with the source inductance effect. Okay, so there also without doing anything, if we are getting the same pattern, means there also it will be same. Okay, so there also what will be the actual angle plus the mu we can apply. Okay, so I am starting with the inverter part. So some 10-15 questions I have
Hello.
taken. Yes, you can ask.
Sir, one more thing I want
Okay.
to confirm that sir, in case of single phase half wave, the time period will be 1 by 2 pi, means 2 pi.
Okay. Single phase half wave you are
Like,
asking.
yes, sir. And sir, in case of a single phase full wave, it is pi, but in case of 3 piles, it
See,
is pi by 30.
I'm telling you why. So let's say this is half wave rectifier. Okay. Single phase, half. All three I'm drawing together. This is single phase half wave, and this is full bridge. Okay. Let's say full bridge.
And sir,
And
3 pulse.
three pulse. So all I'm drawing, all the waveforms I'm drawing. Okay. So this one, what will be the waveform? This is some alpha to pi, and this is 2 pi. Again, it will start from here to here. Okay, let's say this is single, so dual pulse, so it will come as alpha to pi. One second, is it visible? Okay, so it will 2 again pi plus alpha to 2 pi, pi plus alpha to 2 pi. So what is the average value? Average means 1 by t. Okay, 0 to t ft dt. This is the average formula. Okay, so if you will see the waveform, it is repeating after every 2 pi. Clear?
Yes,
So
sir.
that's why here we are taking 1 by 2 pi. But in 2 pulse, if you will see, it is repeating after every pi. So this is the time period. So that's why 1 by pi 0. This is the normal average formula, average of any waveform. Okay.
Yes, sir.
Since this is repeating at every pi, same waveform we are getting at. So what is the cycle of this output waveform? That is pi. Similarly, in 3 pulse waveform, same kind of 3 shape will come in 360 degree. Okay. So what we will say? This 2 pi by 3 is the cycle of the waveform. Is it clear?
Yes,
Hello.
sir.
Okay, because of that period is pi, that's why we are using 1 by pi. So this is the norm generalized average formula 1 by t 0 to 2 ft dt, where t is the time period of the waveform. Okay. Okay.
Yes, sir. Sir, this time period always will come like if it is semiconductor, then it will follow this
See, you
same
have
rule.
to observe the output voltage waveform everywhere. So if output voltage waveform will be repeating in every 2 pi, then it will be 2 pi. See, here this waveform is repeating in every 2 pi. This is one cycle. But if you'll see here, see, if you will take 2 pi, then you have to integrate from 0 to 2 pi. But where we are integrating if full cycle, if you will take, you can take that also. Let's say I'm taking 0 to 1 by 2 pi. So alpha to pi, I have to integrate one term plus pi plus alpha to 2 pi. Then we'll get the same thing. Okay. Is it clear?
Okay.
Okay. It's okay. I'm moving to the inverter portion. So inverter part, most like single phase, today I will do all the concepts and questions I have taken. Okay. So we'll go one by one. So this is the half bridge configuration, where normally either in exam it can be replaced with two DC source. Here they can give one DC source VDC by 2. Here also it will be VDC by 2. Either a source will be there and two capacitor in series. They will, this kind of configuration they will connect, such that if you apply the voltage division, here it will come VDC by 2 and here also it will come VDC by 2. Okay. So switches, we are operating at time period of T. So let's say if switch one, what will happen? That this is the load. Okay. So this VDC by 2 will come at output. So directly I'm going to draw the output voltage V naught. So time period is T. So this will be VDC by 2. Source voltage I'm taking. So V source by 2, Vs by 2, and this will be minus Vs by 2. Here to here, T by 2, and total time period is T. Okay. So how inverter will work? If switch this one will be on means output voltage will be VDC by 2. 2 on means VO is equal to minus VDC by 2. And these two are complementary switches. When one will on, two will be off. When two will on, one will be off. Is it clear? So we'll get this kind of waveform in the output. Is it clear?
Sir, why this diode is connecting here?
See, diode it's connected because if load current will be in reverse direction. Okay, like if we are getting some sine kind of waveform or triangular kind of waveform, so that will not flow through this, because this kind of thyristor or something, if we are using unidirectional switches, so that will not allow the flow of current in reverse direction. Okay, that's why we kept diode here, such that if current will flow in reverse direction, then this will take care of that. Okay, I will explain next part, inductive load. So in for inductive load, how the current will flow, that part I will explain. Okay, is it clear? Up to now it is clear. So normally this
Yes, sir.
cycle will take at 50 hertz. 2 pi is equal to 50 hertz, means 20 millisecond. 50 hertz means 20 millisecond. So what is the Fourier of this one? Already we have seen in the source current, this source current of single phase full bridge. Okay, that was also same kind of waveform. So 4 into Vs by 2, 4 BTC by n pi into sine n omega t. This is Vsn, nth harmonic. N is equal to 135. So it will be 2 VDC upon n pi sine n omega t. Should I derive the Fourier of this one, or is already it's clear? It's one step we can derive. It's not a very. Should I
Sir,
derive this?
Fourier, sir, hello, sir.
Ah, yes, you can ask.
Sir, Fourier generally we want to calculate harmonics present in our wave.
Yes, see, Fourier means every non-sinusoidal waveform can be represented as summation of various sinusoidal waveform. Okay. So if several sine wave we will add, that will construct a square wave. So a square wave, 50 hertz, I want 50 hertz sine wave. So it will have 50 hertz sine wave also and other harmonics also. Yes, correct only. To calculate the harmonic and fundamental value, we are doing the Fourier analysis. Is it clear? Hello?
Yes, sir. Then, sir, we have to see this is half wave, symmetry, or full wave. Then we will
Ah,
calculate
yes. So,
accordingly.
yes, like that we can calculate. So this is half wave symmetry also here. Should I derive the equation Fourier or should I proceed further? If
Sir, if it is asked in gate exam, then yes, we can do.
gate exam derivation they will not ask, directly formula we have to memorize this one. Okay. So if new kind of waveform they will ask, like very random kind of waveform will be there, then we have to go for like basic, we'll see the symmetry of the waveform. Okay. Then we'll do the, like mostly they will give, if they will give random waveform, 100% sure that symmetry will be there. Okay. So you see the odd or even symmetry, then half wave symmetry, then already I have told that formula, that 4 by t 0 to t by 2. This we can apply. Okay. Like if you'll see here, this waveform only, this is VDC by 2 and here minus VDC by 2. Here t by 2 and t by 2. And if you'll see here, this will come like this one. So which symmetry is this waveform? Odd symmetry. Is it clear? Odd. Odd means x of minus t,
Yes,
x
sir.
of is equal to minus xt. Okay.
Minus
And
experience.
if we'll do xt minus t by 2. So if we'll shift this one here, so xt minus t by 2 is equal to, this point will come here. So it will be minus xt. So half wave symmetry is also it is following. Okay. So directly we can integrate 4 by t means t I am taking as 2 pi. Okay. This time period is pi. 4 by t 0 to how much? T. T by 2. And this VDC by 2. This is Bn value. Since it is odd, n will be 0, only Bn we can calculate. Sin nt dt. Okay. So this 2, okay. 4 by t. T is how much? 2 pi only, na? And this is, so VDC by, 1 second, 2 will not be there. 1 second. So it will be VDC upon n pi. Okay. And this will be minus cos nt 0 to pi. Is it correct? Hello.
Yes, sir. Is it correct? Yes, sir. It is correct.
So it will be VDC by n pi. This will be 1 and it will be minus cos n pi. Okay. So for n is equal to 1, 3, 5, particularly this value, and 2, 4, 6. So 2, 4, 6, this will be 1 minus 1, it will be 0. So it will be 0, 1, 3, 5, it will be 2 VDC upon n pi. Okay. So this is what I have written here. 2 VDC upon n pi sine n omega t. The Fourier will be Vs of n will be, V of n will be 2 VDC upon n pi sine n omega t. Is it clear? It will be only non-zero for 1, 3, 5. 2, 4, 6, it will be 0. Okay. Should I proceed next? Hello? Can anyone reply?
Yes, sir. It is correct.
Okay. So see, now I'm going to analyze the circuit with the inductive load. So if inductive load will be there, what will be the current waveform and which diode or switch will conduct? Okay. So I'm going to draw the output waveform. So this is VDC by 2. Again it is VDC by 2. Okay. This is VDC by 2 and this is minus VDC by 2. And here this inductor current will be like some ramp kind of thing. Okay. If you'll see VL is equal to L di by dt. So I will be V by L into integral dt. So it will be some ramp kind of thing. What will happen in steady state? It will oscillate between these 2 points. Let this is I max and I mean. Okay. And here to here it is T by 2. So we'll see if VDC by 2 is there. Output voltage is, where is the output voltage? Plus and minus. That is previous what we have taken. He said plus, this side minus. So here it is plus, minus. So if S and this will work. So current is positive means which will conduct? Which will conduct here? Current is positive means this switch will conduct. So this S1 will conduct here, and here voltage is positive but current is negative. So current, this switch will not allow flow of current in this direction. So current will flow through diode in reverse direction since this is negative current. Okay. So here D1 will conduct. Similarly here we'll see here here which will conduct if the current is positive. Positive means current is flowing in this direction. In this direction. Okay. Which will conduct? Here diode will conduct.
One.
That since this switch cannot conduct in reverse direction, so diode will conduct here. Okay. Here diode D2 will conduct, and again here S2 will conduct. Is it clear? This
But sir,
conduction.
how diode will be?
See here output voltage is negative. Okay. It means that it will be connected in this circuit. This is plus, this is minus. So if this is connected to Vs by 2, then only we are getting output voltage as negative. Okay. But since our current is positive, positive means it will flow in this direction. But this switch will not allow flow of current in reverse direction. Okay. That's why for this case, what will happen? D2 will conduct. Because the current is positive. Is it clear? See, this is
It
minus.
means inductor is for same into in all conditions.
I am drawing this this as inductor current. This yellow color is inductor current. Okay, IL. So if here we need output voltage as negative, but inductor current as positive. Okay, so that will be taken care by this diode. Is it clear? Is it clear?
Yes,
Hello.
sir. Yes, sir. It is clear.
Okay. So here we can calculate the peak value of this current. This is asked in one gate question. So let this is T by what will be this value? T by 4. Here to here it is T by 2. Okay. So we can apply the slope rule. What will be the slope of this curve? Let's say here is T by 4. So minimum value and maximum value. So I max minus I max minus this value how much? 0. 0 divided by how much this duration? T by 4. Is it clear? Can we write the equation of this line? So I'm going to draw the, I'm going to write the equation of this straight line. This is one straight line. We can write the equation. So this is coordinate 1 and this is coordinate 2. Okay. Coordinate 1 how much? X value how much? Here. P by 4. Y value 0. And what is the coordinate this one? X value how much? Can anyone tell? X value will be t by 2 and y value will be I max. Is it clear? Can anyone reply? So what is the straight line equation?
What, sir?
Y, yes,
Sir, what you said? T2 y.
which one? 1 second, you can ask again.
Sir, here in peak of inductor current.
See, that is here to here. If you'll see, this is x axis, this is y axis. Okay, so if you'll see this point, so here to here x axis is t by 2 and y axis is I maximum. Okay, if you'll see this point, x axis is t by 4 and y axis is how much? 0. These 2 points. So I'm going to draw the equation of this straight line. Okay, it clear?
Yes, sir.
Okay. So see, y minus y. What is the equation? Y minus y1 is equal to y2 minus y1 into x2 minus x1 into x minus x1. This one is the x minus x1. This is the equation of the straight line. So same thing I am going to write for this one. So y means I, IL. IL minus I1. How much? This one, y is I. So IL minus 0 is equal to slope how much? Y2 minus I1. So that will be T by 4. No, I max divided by T by 4 into how much? This value will be x minus x1. What is the x value? T minus T by 4. Is it correct? Can you reply? So what will be the IL equation? Hello? Hello? Can you
Yes,
hear
sir.
me?
Yes, sir. Your voice is coming.
Okay.
Sir, y2 equal to I max, but y1 equal to.
See, y1 distance this is x axis. So that will be 0. No y coordinate is there. No? Y coordinate is 0 here. Okay.
Okay.
So this value will be, IL will be 0 at which value? At T by 4. So we can write this. IL is equal to 4 I max by T. So 1 second. IL is equal to here 4 into I max by T. 4 into I max by T into T minus how much? This is T by 4. T by 4. Okay. This is IL equation from this straight line. So this inductor current will be 0 at which value? T by 4. So if we'll put T by 4, this will be 0. Okay. But how we can calculate the maximum value from here? 1 second. Hmm. If 1 second. The final slope value already I have written here, so that we can derive later also. That slope value will come Vs into T divided by 8L. Okay. So I think we have to apply that equation. VL is equal to L di by dt also. Okay. VL is equal to L into di by dt. So what is the slope? Di by dt is equal to Vs by L. Vs by 2L. Vs by 2 by L. Is it clear? So this one data we have to apply also. Okay. So that both slopes should be same. Is it clear? So this slope, 1 second. This slope and this slope should be same. Okay. Is it clear? See, if we'll solve this equation, then finally we'll get that I max is equal to Vs into T divided by 8 into L. Okay. This we can solve with some just by doing some here and there. It's easy only. These 2 points are there. This is one line. So here across the inductance we are applying the voltage VDC upon 2. Okay, this voltage is applying across the inductance. And this is VL is equal to L di by dt. This equation is there. And we can apply this slope also. It will be maximum at T is equal to T by 2. Okay. It will be maximum at T is equal to T by 2. So that value if we put, we get this one. So here if we put, one second. So what is the slope? We can write here. The slope is there now. The slope I am going to write in terms of inductive and that value. So IL will be Vs upon 2L. This is the slope into T minus T by 4. Okay. So if I will put T is equal to T by 2. Okay. So T by 2 minus T by 4, how much? That will be T by 4 only, I think. So that will be Vs upon 2L into T by 4. That will be Vs into T upon 8L. So this will be IL max. Is it clear? This will be the equation of the current, and it will be maximum at T is equal to T by 2. Is it clear? Otherwise I will explain again. See, this line is there, inductor current. This is a ramp signal. Okay. We know the equation of line. This is the slope value. So what will be the slope? Slope will be VL is equal to L di by t. Di by dt is equal to VL by L. What is VL value? VL is Vs by 2. Vs by 2 by L. So slope will be Vs upon 2L. Okay. That value only I have kept here. So IL is equal to slope into T minus T by 4. Is it clear? Is it clear to all? Hello? Can
Yes,
anyone?
sir.
Okay. So see this peak value question already this is asked in gate. Like what if this kind of circuit will be given? What will be the peak value? So peak value will be for half bridge it will be Vs into T divided by 8 into L. Okay. Same thing I will do for full bridge also. So I will go quickly one by one. Then we'll move on to the questions. So some 10 previous years questions I have taken that will solve one by one. So this is full bridge inverter. Okay. So here, if 1 and 2 will be 1, what will be the output voltage? That will be plus Vs. Okay, so it will be plus Vs. And here it will be minus Vs. This is plus Vs and this is minus Vs. Okay, it clear? Here 1 and 2 will be on and here 3 and 4 will be on.
Sir, here why anti-parallel is not
No,
connected
I've
here?
just not given. We can connect here also. So here also it should be connected. I think in our next case I have given that. Here I have connected with a load. Here also it should be connected. See, if inductive load will be there, then only that will, but for resistive load, current will be in same direction. So for inductive load, these diodes are required. Okay. So like this it will be. But since resistive load is there, current will flow in only in one direction. So what will the current waveform? Current waveform here it will be same, V by R. So that will be same. Okay. So see here to here, current is positive. The current is positive means switch will conduct only. So here in case of resistive load, like any question can be given, like only resistive load will be there. Then they will ask what will be the conduction time of the diode. So in case of resistive load, diode will not conduct. Is it clear? So diode will conduct only when
Yes,
the
sir. Yes, sir. Yes.
current will be negative. Okay. So for this one, what will be the Fourier analysis? So Fourier will be 4 into Vs upon n pi sine n omega t. Waveform will be same, is same here. Okay, but magnitude is Vs here. So that's what is the magnitude? Previously magnitude what? Vs by 2. That's why 4 into Vs upon 2 divided by n pi sin n omega t. So we got in case of half bridge 2 Vs upon n pi sin n omega t. Okay. But full bridge, here it will be 4 Vs upon n pi sin n omega t. What will be the RMS value of this waveform? Can anyone tell? What will be the RMS value?
Vs.
That will be Vs only. Since it is appearing for all the duration, it will be Vs only. And this is the Fourier analysis. N is equal to 135, it will give output voltage, and 246, it will be 0. Okay. So quickly I'm moving to that inductor current path. So I will draw the waveform quickly here. Let's say this is purely inductive load, and here it will be like this output voltage, and inductor current will be somewhat here. So it will be a triangular waveform here also. Okay, this is VDC. No, this is okay. VDC or VS. Actually, I have taken VS here. So VS minus VS. This point is T by 2 and this point is T. Okay. So here if we'll do that same thing, this is T by 2. Okay. So what is the slope here? First we'll do the where which will conduct. Okay.
Sir, that one T by 4 now, sir.
Here it will T by 4. So here which will conduct? I'm asking all of you, like which will conduct here? Switch will conduct or
Sir,
diode will?
since current is negative, so sir, diode will conduct.
Which diode? This is the current direction. Okay. This is plus, this is minus.
Sir, D2.
So D1 and D2. So see, if this will be positive, what will happen? This S1 and S2 will conduct. But since this current is negative, this D1, D2 will conduct. So here D1, D2. But here to here, which will conduct? Here to here, current is positive. So S1, S2. Okay. Again, in this section, which will conduct? This section, which will conduct? Output is
S3
negative.
is 4, sir.
Negative. Okay, let's see. S3 and S4. S3 and S4, but current is positive. Current is positive means can it conduct in this direction?
No, sir.
No, sir.
So here it
Sir,
will be
D3, D4. D3, D4.
D3, D4. And again here this is negative means in this direction. So S3 and S4 will conduct here. Okay. And in same way we can write the maximum value of the current here also. So what is the slope here? VL is equal to L di by dt, and di by dt will be Vs by L. Okay, there it was Vs by 2, that why slope was Vs by 2L. See here. Here it was Vs by 2, slope I have taken was Vs upon 2L. But here it will be, one second. So I of L equation will be Vs upon L into T minus how much? T by 4. This only was the, so T is equal to T by 2. This point is T by 2, we'll get the maximum value. So if I put a small t is equal to T by 2, then I will get Vs into T by 4L. That will be the peak. Is it clear? Vs into T divided by 4L, peak value of the current. Should I proceed further? Hello?
Yes, sir. Yes, sir.
Okay. So one method is there, single PWM. Okay. Single PWM, this is very important concept for GATE. On this many times they have asked the question. So single PWM means what we are doing, we are taking a carrier signal and a reference signal. Both signal will have the same frequency. Okay, this square signal is reference signal and this LO signal is carrier signal. So how it will work? If this LO signal is greater than the, this carrier signal is greater than the reference signal and this reference signal is greater than 0. If this case is satisfying, then S1 and S2 will on. And if this carrier is less than the reference and reference is less than 0, It means this case for this duration S3 and S4 will be on. Okay. So this is the single PWM. Is it clear? This up to now what I
Sir,
have
what
explained.
is carrier wave, sir?
See,
Like,
see, carrier means triangular wave we are taking. This is the triangular wave we are taking. Okay.
sir, these are the externally supplied to the PWM.
No, no, this is logic. Some logic is there. Okay. Some logic is there. Based on this, we are generating PWM signals for the switches. Okay. So how this logic will work? This is the logic. If carrier is greater than reference, okay, I have simply drawn this one. If carrier is greater than reference and reference is greater than 0, so it is satisfying here to here only and for this duration, here to here. Okay, so then we have to on the S1 and S2 switch. So here to here only we will apply the PWM to S1 and S2. Similarly, if carrier is less than the reference and reference is these two condition will satisfy, then we'll apply to S3 and S4. Is it clear?
Yes. Okay. But sir, how we can do this?
See, this logic we can generate. If you want to generate this kind of PWM signal, we can write code for this one. If it is logic, we can apply and we can write the code for this one. You want to apply in hardware like you are telling?
No, actually, yes, sir. I am telling about practical, but how it is possible?
See,
Like I am.
practical means like controllers are there. So there, this kind of signals will be there. Okay, we can apply this logic. If carrier will be greater than reference and reference will be greater than 0, then S1 is equal to 1 and S2 is equal to 1. Like that, you can write the coding. Okay. Similarly, we can write for this one also. If and so if these two conditions will satisfy, then we'll give high to this one, else that will be 0. Okay, if else condition we can apply, then we can with these two signals we can generate this kind of PWM signal. Okay.
Okay, and this is output of our
See,
inverter of
output of the
this.
inverter. So this is, let's say, this is, we can say PWM signal also. The PWM for S1, S2. Let's say this is PWM. Okay. So PWM for S1, S2, and this is for here. 1 second. I will omit and draw again. 1 second. So here to here PWM signal will be there, and here to here also one PWM signal will be there. For this is for S1, S2, S3, S4. Okay. So what will be the output voltage? So S1, S2 output voltage will be this one, and S3, S4 output voltage will be this one. Is it clear? So if you see the waveform, what will be this value? Here it will be at middle, it will be pi. Here it will be pi by 2. Is it clear? So
Yes, sir.
this we call as a pulsed width. Here to here pulsed width. Okay. So this section I am assuming as 2D. Okay. Normally it will be called in this syntax only. So this 2D means what will be this value? Here to here it will be d by 2. So this point we can write as pi by 2 minus d by 2, and this point will be pi by 2 plus d by 2. Is it clear? So normally in question they will give single PWM kind of question and they will give the pulse width, or they will ask what will be the pulse width. So pulse width will be 2D. This 2D I am taking is the pulse width. So that will be this middle. See, this middle point will come at pi by 2. Okay. So this will be pi by 2 plus d by 2, pi by 2 minus d by 2. Is it clear? So I'm going to do the Fourier analysis for this one. Okay. It will not take more time. So this is the waveform, output voltage. This here pi by 2 and here pi, and again which symmetry it is following, we'll see. It is odd and half wave already, no need to shift. Odd and half wave symmetry is there. Okay, so directly Bn we can calculate. Bn is equal to 4 by 2 pi. Okay, and 0 to pi. So 0 to pi means it will be here we can directly apply for this section only. It will be so pi by 2 minus d and pi by 2 plus d. Okay, so this will be pi by 2 minus d and this will be pi by 2 plus d, and this is Vs. So Vs sine nt dt. Is it clear? So it will be 2 Vs upon n pi into minus cos nt into this only pi by 2 minus d and pi by 2 plus d. Is it clear up to now? Bn value. So it will be 2 Vs upon n pi, okay, and minus cos n pi by 2 plus nd plus cos n pi by 2 plus nd. Is it clear up to now? So cos A plus B formula is cos A into cos B minus sin A into sin B, and here also cos A into cos B minus sin A into sin B. Here it will be minus. See, so this is cos A into cos B minus cos A into cos B plus sin A into sin B, and it is cos A into cos B plus sin A into sin B. So what will be the actual value after addition? 2 sin A into sin B. Is it correct?
Yes,
Hello.
sir.
So that will be 4 Vs upon n pi. Since 2 I am taking outside, sin nd into sin n pi by 2 sin n pi by 2 into sin nd. Okay, this is Bn value. So what will be Vs of n? Nth harmonic will be 4 Vs upon n pi sin n pi by 2 sin nd into sin n omega t. This will be the nth harmonic component. Okay, is it clear? Hello.
Yeah, sir. Yeah. Sir, it is the nth harmonic components of voltage,
For this
output
one.
voltage.
This is output voltage. And what will be the RMS value of this one? This is 2D. This is also 2D. Okay. So RMS will be, VO RMS will be Vs into 4D divided by 2 pi. In 2 pi, it is conducting for 4D. Okay. So Vs into 2D by pi. Is it correct? So this is actual RMS value. This is harmonic RMS. For fundamental, we can put n is equal to 1. So this will be the peak value. We can divide by root 2. Is it clear? For third harmonic will be there here. Can you tell which harmonic will be there? Even will be there. If I am putting 2, 2, 4, 6 will be there. Can anyone tell? See this factor, what will happen? 2, 4, 6, it will be 0. So
0, sir.
n is equal to 1, 3, 5 only it will be there. That also we can eliminate some harmonic based on this lead. Okay, sin nd. Sin nd. If this factor will be 0, let's say third harmonic I want to eliminate. Okay, so sin 3d should be equal to 0. So what is the this value? It will so 3d should be equal to pi or 2 pi. Okay, or 4 pi. This only will be sin pi is how much? 0 only. Anyone tell? See, so this will be the value.
Yes, sir. Sin pi is 0.
So d will be pi by 3, and 2d will be
60.
width will be 120. Okay, and one condition we have to see here. Our d should be less than. See, this is 2d. Okay, So 2d should be less than pi. This condition we should satisfy. Okay, other option also we can see, like let's say 2 pi, if 2 pi will be there. So 2 pi divided by 3, how much? Hello? So d is 4 pi by 3. 4 by 3 means less than pi or greater than pi? Greater than pi. So that will not be acceptable. Is it clear? Can anyone reply? I will discuss again. See, this whatever the 2d value we are calculating to eliminate the harmonic,
Sir.
that should
Yes,
be
sir.
less than pi. 2d should be less than pi. Okay. So I want
Sir,
to
why?
see, if you'll see this waveform, because this should be under this pi only. If will maximum it
Okay,
will be
okay,
pi.
yes.
Okay. Maximum it
Yes,
can
sir,
go up
yes,
to
sir.
pi. Okay. So
Yeah.
if I will consider this 2 pi, let's say I'm considering 2 pi. Pulse width 3d is equal to 2 pi. So 3d is equal to 2 pi means d will be 2 pi by 3 and 2d will be 4 pi by 3. But 4 pi by 3 how much? 240 greater than how much? Pi. So this is not acceptable. So what will be the answer?
Yes.
Maybe this kind of answer also will be there in the option, but we should select this only is the valid range. So pi by 3 means 60, 60 into 2. 120 should be the pulse width. Is it clear? Clear up to now?
Yes, sir, yes, sir.
Okay, so some 10 questions I have taken. I will solve one by one. So this is the first question asked in GATE 2017. So what will be the RMS value of the fundamental component of the output voltage? Okay, how we can calculate? What is the
Sir,
formula?
Vs into
4
Vs
into
into
4 Vs upon n pi into sin n omega t. This is the output nth harmonic voltage. What will be the fundamental peak value? So fundamental peak will be 4 into Vs upon pi. This is V01 peak. And what is the RMS value? So this divided by root 2. So that will be 2 into root 2 into Vs upon pi. Is it clear? Can you calculate this
sir,
value?
sir.
Yes, you can tell.
Earlier we have calculated Vsn equal to 4 Vs by n pi sin n pi by 2 sin nd sin
See.
omega t.
Got it. That is for single PWM. Here the question
Okay,
is not
okay.
single. This is single PWM means already it will be mentioned in the question. Okay. This kind of question they will mention either some kind of a statement will be there, but this is see here. See the question. A converter shown below where switches are controlled such that VOT is a 400 Hz square wave. So 400 is a square wave means it will be a square wave. Okay. So what is the this is normal square wave. Okay, that question also I have taken. It will come at next. So then it will be more clear. So this is a normal square wave. So what is the RMS value of the square wave? Fourier analysis. So this is Fourier for normal square wave. Already here it is written that this is a square wave. Is it clear? Clear now?
Yes, sir, it is clear now.
So what is the answer? I have calculated 2 into root 2. 1 second. Anyone calculated?
Yes, sir, it is
Uh,
198.06.
198.06. Correct. Okay. Then moving to the next question. Hmm. So
Yes,
this
sir,
is
yes.
yes.
Sir, sir, you have put the value of Vs equal to root 2.
Where? Can you repeat
Sir,
again?
this 2 into root 2 into Vs by pi.
See, this is maximum value of the fundamental voltage. What will the RMS? RMS will be V01 by root 2. So that will be 4 into Vs by root 2 pi. Okay, this is the RMS value. So 4 by root 2 means it will be 2 root 2. Is it clear?
Yes, sir, now it is clear.
Okay.
Sir, 198.06.
Correct. Next question, this is asked in GATE 19. Okay, so see here, we'll read the statement one. Output voltage of single phase full bridge voltage source inverter is controlled by unipolar PWM in one pulse per half cycle. Okay, so this kind of a statement means it is single PWM, one pulse per half cycle. Okay, now for fundamental RMS component of output voltage to be 75% of DC voltage, the required pulse width in degree. It means they are asking what is the value of the 2D. Okay. If this kind of a statement will be there, like half pulse, one pulse per cycle, single PWM, okay, and pulse width, then it will be come under this section. So what is the formula already we know? VO of N is equal to 4 Vs upon N pi into sin N pi by 2 into sin Nd into sin N omega t. So we have to calculate the pulse width. Okay. Fundamental RMS component of the output voltage 75% of DC voltage. It means what is the RMS value? 75% of DC means 0.75 into Vs. This should be equal to 2 into root 2 into Vs upon pi into sin D. Is it clear? This is fundamental RMS value. Okay. This should be equal to 75% of the DC value. Is it clear? This statement is only written here. Clear to all? Hello? Can anyone reply?
Yes, sir.
Okay, so from here we can calculate the D value. What is the value of the D? Okay.
Sir,
So
sin omega t term.
see, this is RMS value. What is the statement is given here? The fundamental RMS component of the output voltage. So this is the peak value up to here to here. Okay. Peak value divided by root 2 will be the RMS value. N will be 1, then it will be fundamental. Okay. So this value I kept N is equal to 1 and divided by root 2. So this is the RMS value of the fundamental. Is it clear? Hello?
Okay.
Yes, sir. Clear.
Okay, so from here we VS will cancel. So sin D will be D will be sin inverse. Anyone have calculated D? Sin inverse 0.75 into pi divided by 2 root 2. This is repeated question they will ask on this concept. Okay, this is VVI. Every year they are repeating. So 56.41 I am getting. D will be 56.41 degree. Everyone got this value?
I sir 56.41 degree.
So what will be the pulse width? Pulse width means 2D. This is fill in the blank type question. Okay. By mistake we can fill this also. The pulse width is 2 into D. That will be into 2, 112.82. So 112.8 degree is the answer. Is it clear?
Yes, sir. Sir, okay, sir. It is clear.
Okay, okay. Moving to the next question. This asked in I think 20. See, same question. In 20 also they have asked. This is in 90. This is in 20. So in single phase inverter is fed from 100 volt DC source and is controlled using a quasi square waveform modulation scheme. Same different kind of language they will use. Okay. Same thing is there but different kind of language they will use. Quasi square wave modulation index, the sigma is adjusted to entirely eliminate the third harmonic component from the output voltage. Under this condition, the magnitude of the fifth harmonic component add a percentage of magnitude of fundamental component. Okay. So we are eliminating the third harmonic and then we have to calculate the ratio of fifth harmonic to the fundamental. Okay. So what will be the pulse width for third harmonic elimination?
60 degrees, sir.
16 D will be 60 degree, I think. Okay. So 3D will be pi, D will be 60 degree. Okay. So this value will calculate V5, V0, 5, V5 divided by V1. That's what they are asking.
4
That
Vs by N pi.
so it will be 4 Vs divided by how much it will be 5 pi fifth harmonic into sine
Sine
5
5D.
5 into 60 divided by 4 into
4
Vs
Vs by
divided
pi.
by pi into
Sine 60.
sine 60. How much we are getting?
20%, sir.
Correct, 20%. Everyone got this value? So this you should remember, like this is a standard concept. Like most I have seen many questions based on this concept only. Like power electronics is like if they will ask tough question, then it is tough. But if you know this small concepts, then easily you can fetch good marks.
Sir, in each case, we will remove the sine omega term for
See,
VRMS.
yes, RMS means let's say this is any sinusoidal voltage, Vm sin omega t. Okay, this is sine waveform. So what will be the RMS? Let's say this is VA. RMS will be maximum by root 2. It clear? So sine omega t is the sinusoidal quantity. Other than that, what is there? It's the peak value. Is it clear? It's normal like
Yes, sir. And okay, sir.
phasor concept. That you should do. There only we can do mistake. In some case, what they will
And sir,
ask,
we will calculate here RMS only.
yes, some question they
Yeah.
will ask amplitude. Okay. In case of RMS or something, amplitude like one time they have asked. So amplitude means peak value. Okay. If they will ask amplitude, then no need to divide it by root 2. That is means peak value. Okay. So language we should take care what they are asking. Either they are asking RMS value or peak value or amplitude. Amplitude means peak value. Okay. One time I have done this kind of mistake. Like they have asked amplitude, but I have filled their RMS value. So that thing you should take care. I should read the question carefully. Okay. So I'm moving to the
Sir,
next.
sir, D
Yes.
equal 30 degrees. What is this, sir?
See, D is 30 degree means this is 2D. Here to here, already I have derived this one. I'm not seeing the sigma value. This is 2D. Okay. They are telling in terms of sigma, but no need to see that. Okay. Sigma also, if something will be there, that will be related to this only. So pulse width, already I have derived now this kind of waveform. See here. This kind of waveform is there, but they are mentioning this value. They are adjusting this value. They are telling that they are adjusting this LO value such that it means if they will increase it, our D will decrease. If they will decrease it, our D will increase. So indirectly, is it clear? So we already know the waveform in terms of this 2D. Okay.
Okay,
Hello.
sir. Okay, sir.
Just they wrote frame the question in different way to confuse. It is same only. Okay.
Yes, sir. And sir, what is the meaning of quasi square wave
Quasi square
modulation?
means a square wave will be there, but some part will be zero. Okay. This is a square wave, but some part will be zero. This is normal square wave, but if it a square wave will be like this, it will present for some time and some time in this negative, then that will called as quasi square wave. Like source current of the semi converter, also we can say. Source current of the semi converter also it will be a quasi square wave. Is it clear?
Sir, but in question not given D equal to 30 degrees, no, sir.
See, question it is not given that we should not see. They are asking this one, third harmonic elimination. The sigma is adjusted such that to entirely eliminate the third harmonic. Okay. I'm not neglecting the sigma. Let's say sigma some value. So, but I know the equation of this waveform in terms of this 2D. Okay. So if sine, I will write in my form only. Like let's say they are varying the sigma, okay, but they are varying the sigma means they will be varying d also indirectly. Is it clear? But I know
Yes,
the
sir.
equation in terms of d. So what is the for third harmonic elimination? Sin 3d should be equal to 0 and 3d should be equal to pi and d is equal to 60 degree. Is it clear? So
Okay, okay, sir.
we can write the this Fourier in terms of sigma also, but since I know in terms of d, that only I am using. Is it clear?
Yes, sir. Clear, sir.
Okay, okay. Moving to the next question. So this is asking GATE 2001. Okay. They are asking the conduction time of the each feedback diode in cycle. So I'm going to first draw the waveform. Okay. This is output voltage. Okay. And here it will conduct. So this is the current. So here which thing will conduct? Current is what will be the current is negative. Okay, negative means D1 D1 D4. So here D1 D4 will conduct
D1,
and
D2, sir. That one.
D1 D2
Yes,
D1
sir.
D2 conduct.
T1, T2.
And here which will conduct this side. So if we'll see each diode they are asking now. If the average load current, what is the time duration conduction of each feedback diode? So since here D1 D2 is conducting, similarly here which will conduct? Current is negative. So here T1 T2 will conduct, I think. Here D3 D4 will conduct. Okay. So what will be the conduction time of each diode? T by 4.
5 milliseconds, sir.
Okay. So one cycle is 20 millisecond and T by 4 will be 5 millisecond. This is the correct option. Is it clear to all?
Yes, sir.
Okay. Okay. Now this is the next question. Anyone can tell the answer? What will be the answer for this one? GATE 2002. GATE 02. So this is the uh, what is there? So this is a PWM signal for the switches. Okay. No. 1 second. Semiconductor switch on operated such that the pole voltage V10 and V20 are given here. So this V1 with respect to 0 and V2 with respect to 0 are given here. So what will be the RMS value of the pole to pole voltage V12? So what is V12? We can write as V1 minus V2. Clear?
Yes, sir.
So that waveform will be like this. And here it will be like this. Is it clear? What is this value? 5. And this is also 5. So what will be the RMS value?
Yes, and root 5 I 180.
See, in one cycle, if you'll see here, one cycle is here to here, 2 pi. It clear? So in one cycle, it is conducting for 5. So Vs into 5 by 2 pi. Is it clear? V10 minus
Yes, sir. It is.
this only should be the answer. No?
Yes, sir.
See, this is one cycle is 2 pi, and it is repeating after here. So what will the RMS value? V12 means V1 minus V2. So here, 1 second, no, something here. This is shifted only, I think. 1 second. See here. This is something wrong we have done, I think. 1 second. So this waveform is same only but shifted by 5. Na? 1 second. Since this waveform is same only shifted by 5, so here it will be one waveform will be there and here also one waveform will be there in one cycle. This is 5, this is 5. and this is pi. Is it clear? And here also same thing will come. This is 2 pi. Is it clear now? So 2 pi divided by 2 pi. Let what? Hello? Am I audible? Hello? Can anyone reply?
Yes, sir, it is clear.
Okay. So since this is 2 pi, so 2 pi by 2 pi, it will be Vs into 5 by pi. So correct option will be B. Okay. I'm moving to the next question. 1 second. This is also similar type of question, GATE 2003. Okay. So alpha is 120 degree. It means the same waveform. 2D is how much? 120. What will the D value? D is 60 degree. Okay. So the RMS fundamental component of the output voltage, this value will be how much? So we'll write 2 into root 2 Vs by pi into, hello, yes, not audible?
Hello.
Yes. Am I audible? Can anyone reply?
Sir, screen is not visible, sir.
The screen is not visible. Now? Now it is visible? Hello? Can anyone reply? Hello? 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 Is it visible now? Hello? Hello? Am I audible? Hello? Can anyone reply? Hello? 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 Can anyone reply?
Yes, sir. Yes,
Now?
sir.
Sir, sir.
Okay, okay,
Yes,
okay.
sir.
Actually, maybe some internet issue was there. It was disconnected. 1 second. So, is it visible now? Can anyone tell?
Visible, sir. Visible.
Okay. So, the RMS value will be
0.78 volts, sir.
correct only. So, same formula we can use. Sin ND. Okay. So,
For
2,
Vs.
so 2 into root 2 into Vs how much? 1 only. 1 by pi into sin 60. So, root 3 by 2 means root 6 by pi.
Previous problem we asked only amplitude, sir. In this problem, asked RMS value.
Yes. So, RMS only I have taken here. So, root 6 by 2. Root 6 by pi. 0.779. So 78 is there. What is the answer the second question? We want to free from fifth, so sin 5d should be equal to 0. Okay. Let's say alpha. See here, we have to see carefully. Alpha is equal to 2d. Alpha here is equal to 2d. Okay. So sin 5d is equal to 0. 5d will be how much? Pi.
180.
So 180 by 5, how much? D will be 36.
Yes, sir.
And 2D will be 72. So value of 2D means value of alpha, that will be 72 degree. Is it clear?
Yes, sir.
Okay. Okay. I'm moving to the next question. Wait one second. Wait a minute. One second. 1 minute. Okay, so this question I will solve, but last I am taking some latest question. So this question. So similar kind of question. Okay, GATE 2007. So what will be the TSD? Okay, 2D is equal to 50 degree. So the waveform will be like this.
Sir, one.
150. This is 150, and here also it will be 150. Okay, so what will the actual RMS value? Actual RMS will be Vs into 350 divided by 360. Is it clear? This will be the RMS value of the waveform, VO RMS. Okay, and what is the fundamental value? So fundamental value will be 2 into root 2 into Vs by pi into sin n pi by 2, that will be 1, n is equal to, that will be 1 into sin nd. Nd means how much? D is equal to 75. 2D is equal to 150. D will be how much? 75. Is it okay?
Yes, sir.
So that will be sin 75. Sin 75.
Sir,
Yes.
hello. Sir, VU RMS will be VS into 300 by 360.
Oh, okay,
I
okay.
think.
I did mistake. 300 by 360. So what will be the distortion factor? Already I told you. Distortion factor. So distortion factor is 1 fundamental by Vs. Okay. So we'll multiply by this one. IS1 by IS, or VS1 by VS here it will be. So 2 into root 2 into sin 75 divided by pi. VS will cancel, and that will be 0 will cancel, into under root 6 by 5. Is it correct? VS1 by VS. This value is correct. So we'll calculate the distortion factor. Then what will be TSD? TSD will be 1 by df whole square minus 1. Okay. So how much we are getting this distortion factor?
31.83.
You are getting final answer?
31.83.
Okay. How much is this value? 2 into root 2 into, 1 second. Anyone calculated this distortion factor value? Root 2 into sine 75 into root 6 divided by pi into root 5. Pi into root 5. 0.952 we are getting.
Yes, sir.
0.952. So it will be 1 by 0.952 whole square minus 1. So 1 by 0.952 whole square minus 1. 32.1, almost we are getting same. So that will be, maybe some part I have left here, that's why. So 31.83 is the correct option. Is it clear? The one formula we have to remember, that's only like 4 Vs upon n pi into sin n pi by 2 sin nd sin n omega t. Okay, this is the peak value. Okay, and RMS accordingly we can calculate. Should I move to the next question? Hello, can you reply?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So this question already formula I have derived previously. So they are asking what will be the peak value of the I naught. Okay. So what was the formula for this one? That was I naught peak was Vs into T
ST.
by 4L. This was the formula. Okay. Already we have derived this one. So here directly I will put that 200 is Vs into T how much? 1 by F. So I am going to apply a 4 into L into F. 4 into F into how much is 0.1. This only. Okay, na? How much it will be?
10 mil, 10 amps,
10.
sir.
10
10.
ampere. This is the correct.
10.
Okay. Okay. Easy only. Just if we know the formula, then we can directly apply here. Moving the next question. Again. This is a good question. See, 2014. So this is the inverter is given. Okay. And S1 and S2, these are pulses, triggering pulses to S1 and S4, and S2 and S3 is given. S1, S4, S2, S3 is given. And they are telling that if load current is sinusoidal, 0 at pi, 0 pi 2 pi. Okay. So sine wave will be like this. This is the load current. Okay. Then they are asking, okay, what will be the um, what will be the node voltage VA0? Okay, node voltage VA0. 0 is this one. Okay, so if we'll see 0 to theta. Okay, 0 to theta, our current is positive. Okay, so which will conduct here? This is a sine wave, and this theta to pi minus theta S1 and S4 will conduct. Before that, we are not triggering S1 and S4. So S1 and S4 is not triggered here, but our switch, this which will conduct, this diode will conduct. Is it clear?
Yes, sir.
So if that diode will conduct, what will be the value? Uh, so if you'll see here,
Sir, load we have to assume that R load, sir, or
mhm.
during active load, sir. That one.
Oh, this is load we don't know, but current, load current they are giving. Load current is pure sine. Okay, they are giving as purely sinusoidal. They are not giving as load. So see, which will here 1 and 2 is off. Our switches are 1 and 4 are not conducting. For 0 to theta, this switches 1 and 4 is not conducting, but the current is positive direction. So which will take care of it? This diode, and this diode will take care of this current. So
Oh, sir.
current will flow in this direction. Okay. So if we'll see with respect to A to O, what will be the voltage? This plus and minus VDC by 2. So this minus will come at A and plus. So VA will be minus VDC by 2. 0 to theta. Is it correct? Hello?
Yes, sir.
So we'll see all the waveform. Directly we can see this one and we can tick it because no one have negative. Further we'll analyze. Okay. See, in objective question, if you are getting this kind of thing, there no need to do the full cycle analysis. Up to here, if you are analyzing it is we are getting, then we should tick and move forward. Okay. So theta to pi minus theta, we'll see. Theta to pi minus theta, this 1 and 2 will conduct and current is positive only. So 1 will conduct means what will the value? A and O will be, this C voltage will come, top capacitor. Okay. If 1 and 2 will conduct here, theta to pi minus theta, 1 and 2 means current will flow in this direction, current is positive only. So A to O, what will be the voltage? This plus VDC by 2. Okay. So here to here we are getting plus VDC. Again pi minus theta to pi. So pi minus theta to pi, current is positive only. So which will take care? That same as previous. So that will be taken care by this diode. Okay. So what will happen? Again minus VDC by 2. If you see after pi to pi plus theta, okay. So pi to pi plus theta, current is negative. None of the switches are working. So what will be the which diode will conduct? Anyone tell?
Sir, S2 and S3.
So this will conduct. Now see, current is negative here. Current is negative, so it will flow in this direction, but none of the switches are triggered. So that current will be taken care by this diode and this diode. Is it correct? Here, this duration. Output voltage will be plus VDC by 2. Again, for here to here, current is negative and our switches, which switches 2 and 3 are working. So 2 and 3. So 2 and 3 and current is negative means it will flow in this direction. 2 can conduct in this direction, negative direction. So what will be the A value? A will be minus VDC. Is it clear now? I think it is clear.
Yes, sir. Clear, sir.
Okay, so like that we can analyze the waveform and we can pick the final answer. Okay, so I'm moving to the next question. I think this is asked in 2021. Okay. So a single phase full bridge inverter. See, here also they have little bit trick they have given. Same thing is there, but little bit we have to solve the carefully. So a single phase full bridge inverter is fed by 325 DC, produces a symmetric quasi-square waveform across AB as shown. To achieve a modulation index of 0.8, the theta expressed in degrees should be. Okay. So what is modulation index? That they should define here. So see, define already. Modulation index is defined as ratio of the peak fundamental component of VAB to the DC value. Okay.
4Vs by n pi into sine nd by
That
VD.
same thing, but see,
VAB.
one trick is here. What they have asked, they have not asked any like this kind of value. They are asking an instantaneous value, that theta they are asking. So what will be the theta at this instant? Okay. So we'll see. Modulation index here they have defined ratio of peak value of the fundamental. So peak is how much? 4 into Vs upon n pi into sine n pi by 2. 1 second.
Sine phi d.
Into sine nd. This is peak value. So peak value divided by Vs. This only they are telling, na?
Yes,
Peak,
sir. Yes.
this what they are telling, it is 0.8. Okay, this is equal to 0.8. So Vs will be cancelled. 0.8 is equal to, this n will be 1. Here also it will be 1 for fundamental. Okay, peak of the fundamental. So 4 into okay, Vs will cancel now. 4 into 1 by pi. Okay, into sine d. What will be the d value from here? We'll calculate first. So d will be sine inverse 0.8 into pi divided by 4. 38.92 we are getting D.
Yes, sir, same I am getting.
You also got the same. So what will be the
Yes, sir.
theta value? So D means it is here to here. This is
Yes,
2D,
sir,
na?
it is there.
So
Yes, sir.
theta will be 90 minus D. Is it correct? This instant theta. Here it is pi by 2. So pi by 2 minus D will be theta. Is it correct?
Yes, sir. It is
So
51.07.
51.07 will be the instantaneous this theta value. But many people have done mistake here. They have not thought that what theta they are asking. They put the wrong answer. So we have same formula they are using, but they are making an aptitude kind of question in a different way.
Sir, can you explain this formula? Theta equal 90 minus D.
See, already we have calculated D. What is D? Our pulse width is 2D. Okay.
Yes, sir.
Midpoint is 90 degree. And this instant value is theta. So what is the theta value? Theta will come 90 degree before pi. So theta will be pi by 2 minus D. This midpoint is pi. The here to here is 2D. So what will be this half of this one? Half will be D. Is it correct?
Sir, yes, sir.
So theta will be, theta is the instantaneous value of this point. And
Got
this
it,
is
sir.
okay, okay, okay,
Thank you, sir.
okay, okay. So see, like this way, like if you will be careful in the exam, you can solve the question easily only. These all are 2 marks questions, like fill in the blanks type. I think I have covered up to now. So I think sinusoidal PWM is there. Tomorrow I am planning to, tomorrow everyone is okay for the class. Like I will complete the inverter portion.
Yes, sir.
Yes, sir.
Yes, sir.
So tomorrow I will,
Time,
yes. So
timing?
same timing, 7 to 9. Any other classes are there tomorrow?
No, sir.
Okay. So 7 to 9, same timing will be there. So I will cover tomorrow 3 phase. So main thing is like that will be the more important tomorrow class. So 3 phase derivation I will not do for Fourier analysis. So 3 phase 120 degree, okay, 180 degree. These 2 case I will discuss the output voltage, okay, and Fourier analysis. I will just write the formula. Okay, direct derivation I will write. So that we should remember. Fourier for 120 degree and 180 degree.
Sir,
Yes,
sir, can you take this class 5 to 7 p.m., sir?
5 to 7 tomorrow. Everyone is okay with that time?
Yes, sir.
Everyone is okay? Otherwise,
Yes,
maybe
sir.
I have to set a reminder. Otherwise, maybe because it is mentioned there now, other people will join. Then they will join from 7 to 9. Okay, tomorrow anyway my schedule is not there. So 5 to 7. Everyone is okay with 5 to 7? Hello?
Okay, sir.
Everyone is okay.
Okay, sir.
Okay, okay. So tomorrow 5 to 7 I will take. So what I will cover, we will just give
Thank you,
a,
sir. Thank you, sir.
okay, 1 second. So 3 phase rectifier, okay, not rectifier, inverter, 120 degree and 180 degree. Okay. So here main thing I will discuss current relation for RL load, R load. Okay. So this kind of objective question can be framed. If output current is given, what will be the RMS current of the switches? ISW RMS. Okay. So this short tricks I will give for this one. All waveform analysis I will discuss. Okay. Then Fourier for these 2 case. Fourier of phase and RMS voltage. Okay. Then sine PWM. Okay. For unipolar and bipolar. These two I will discuss, and along with this I will solve all the previous year questions. So whatever the remaining inverter question will be there, that I will solve tomorrow, and I will discuss all these things. Okay. So 5 to 7 tomorrow. Is it okay for all? 5 to 7.
Okay, sir.
Okay.
Okay, sir.
Sir, inverter, so there are problems like to start delta also is there, sir. Three
That
phase.
everything I will cover. Every numerical questions are there. First, I will derive the formula for all in first 1 hour. Okay. It may go up to more than 2 hours also. Then it will also to be okay, na? Because that will be the last session. Like I'm closing tomorrow. Is it okay? Because
Okay, sir.
whatever question, like all invert, most of the inverter questions I have solved today. Whatever the remaining question is there from inverter, that before I will cover the theory part. After that, I will solve all the numerical question. Is it okay?
Sir.
Okay, sir.
Okay. Okay. So thank you all. Tomorrow we'll
Thank you,
meet
sir.
5 to 7. Okay.
Sir, share this PDF as soon as possible.
Now only I will share too instantly. Okay. Thank you all. Thank you.